Video 13, Semantic Search versus Keyword Search. What's the difference? This is part of our literature review and discovery series. Here's the problem. Researchers don't understand why traditional keyword searches miss relevant papers. You search for your topic, get thousands of results, but somehow the most important papers slip through. You find them later through a colleague or citation chaining and wonder, why didn't my search find this? The answer lies in understanding the fundamental difference between these two approaches. By the end of this video, you'll know exactly why semantic search finds what keyword search misses. The problem is that researchers don't understand why traditional keyword searches miss relevant papers. Let me explain how keyword search actually works. When you type terms into PubMed, Web of Science, or Google Scholar, the search engine looks for documents containing those exact words. It's pattern matching. Does the document contain these character sequences? Boolean operators give you some control, and requires both terms, or accepts either, not excludes. Wildcards help with variations, but you're still fundamentally matching strings of characters. Here's the critical limitation. Keyword search requires you to guess the right terminology. If the authors of a relevant paper use different words than you search for, that paper is invisible to your search. You might search work from home productivity and miss highly relevant papers that use remote work efficiency or telecommuting performance or distributed team output. None of those match your keywords, so you never see them. This vocabulary problem is more serious than it appears. Different fields use different terms for the same concept. What psychologists call cognitive load, economists might call mental bandwidth. What computer scientists call machine learning, statisticians might call statistical learning. Terminology also evolves over time. Historical literature uses different language than current papers. The result? When you do a keyword search, you're implicitly assuming that every relevant paper uses your exact vocabulary. That assumption is almost never true. The solution is semantic search, and here's how it's fundamentally different. Instead of matching character strings, semantic search understands meaning. It converts both your query and documents into mathematical representations of meaning, called vector embeddings. Think of it this way. Every concept exists in a high-dimensional space of meaning. Words and phrases that mean similar things are close together in this space. Words that mean different things are far apart. When you search semantically, the system finds documents close to your query in meaning space, regardless of specific words used. Here's the process step by step. You enter a natural language query, not keywords, but a description like research on whether working from home affects employee productivity. The system converts this to a vector, a mathematical representation of its meaning. It compares your query vector to millions of papers. You get results conceptually related to your query, even with completely different vocabulary. A paper about telecommuting effects on organizational output would never match keywords for work from home productivity, but it's close in meaning space, so semantic search surfaces it. This is transformative. You no longer need to guess every possible phrasing researchers might use. You describe what you're looking for, and the system understands your intent. Let me show you the transformation with a direct comparison. Before, with keyword search, you enter terms, it matches characters. Papers using different vocabulary are invisible. You need to know field-specific jargon before you search. Results are based on term frequency and Boolean logic. After, with semantic search, you describe what you're looking for in natural language. It matches meaning, not characters. Papers using synonyms, related concepts, or different terminology still appear. You don't need to know jargon. The system understands your intent. The practical impact is significant. Let's say you're interested in how AI might replace jobs. With keyword search, you try AI job displacement and miss papers on technological unemployment, robotization of labor, or machine learning workforce impact. With semantic search, you ask, will AI and automation lead to job losses, and find relevant papers regardless of how they phrase the topic. The semantic approach finds a broader, more comprehensive set of relevant literature. The impact of understanding this difference is significant. You now understand why semantic search finds papers keyword search misses. This isn't a minor improvement, it's a fundamental change in what's possible for literature discovery. An important nuance. Semantic search doesn't replace keyword search. They're complementary tools. Use semantic search when starting exploration and you don't know all the terminology yet, when crossing disciplinary boundaries, when you want to ensure you're not missing relevant papers. Use keyword search when you know specific technical terms and want precise results, when you need reproducible search strings for systematic reviews, when filtering by specific metadata. Best practice. Start semantic for discovery, refine with keywords for precision. Let me give you the key takeaways. First, the problem is real. Researchers don't understand why keyword searches miss papers, and the answer is the vocabulary limitation. Keywords match characters, not meaning. If you don't guess the exact terms, relevant papers are invisible. Second, semantic search solves this. It finds papers by meaning, not word matching, surfacing relevant work regardless of terminology. You describe what you're looking for in natural language and the system understands. Third, understanding this transforms your literature discovery. You can now find papers you would have missed entirely with keyword-only approaches. Available tools include Semantic Scholar, Elicit, Consensus, and Connected Papers. Each has strengths. Semantic Scholar is comprehensive and free. Elicit is great for empirical papers. Consensus extracts findings directly. Connected Papers visualizes relationships. I recommend experimenting with all of them on your next literature review. The important point, if you're still relying solely on keyword searches in PubMed and Google Scholar, you're leaving relevant papers on the table. The tools exist to find them. You just need to use them. Best practice? Start with semantic search for broad discovery, then use keyword search for systematic coverage. They're complementary, not competing approaches. Here's what I want you to remember. The limitation of keyword search isn't the tools. It's the assumption that you know the right words to search for. That assumption breaks down constantly in research. Semantic search removes that limitation. You describe what you're looking for, and the system finds relevant work regardless of how authors phrased it. This is particularly transformative for interdisciplinary research, for emerging topics where vocabulary isn't standardized, and for researchers entering new fields. In the next video, we'll look at citation networks, another powerful approach to discovering literature you didn't know existed. Welcome back to the Impact or Invisible series. This content comes from the book Impact or Invisible: Surviving the Data Age with AI by Angel Reyes. The research landscape has changed forever, and one of the biggest changes is in how we can find relevant literature. Today, we're demystifying something that sounds technical but is actually transformative: semantic search. If you've ever been frustrated by keyword searches that miss relevant papers, this video explains why and gives you a better approach. For the complete framework on AI-powered research discovery, get Impact or Invisible: Surviving the Data Age with AI by Angel Reyes. The book covers semantic search, citation networks, literature matrices, and every other tool you need for comprehensive literature review. Available on Amazon, link in the description. Next up is video 14 on understanding citation networks. We'll explore how to use the connections between papers to find work that even semantic search might miss. Thanks for watching. See you in the next video.